Hi, and welcome to this learning path, which is a deep dive into the JavaScript programming language. JavaScript is one of the most widely used programming languages in the domain of web development. When building a website, for example, JavaScript is often heavily involved in the client-side part of the application and can also be part of the server-side app. To get a better idea of where exactly JavaScript fits in, let us take a look at web browsers and web servers in general and zoom into where JavaScript plays a role. So imagine a scenario where you wish to browse on the internet. So you wake up one morning and you want to check out the latest news headlines, in which case you decide to check out your favorite newspaper website. To do that, you open up your web browser and then following that, you type in the URL for the news website. Let's just say this URL is www.kennel.com. So once you enter it in the browser, an HTTP request is sent out to the internet. That request is diverted to the correct web server which hosts kennel.com, which in turn finds the home page of your website and then returns it in an HTTP response. It is this HTTP response which is parsed and then translated by your web browser and most likely includes a web page. So let us quickly summarize what has just happened here. An HTTP request was sent by your web browser, so you effectively put in a request for any information related to the URL www.kennel.com. This request makes its way over to the web server, which will hunt for the specific resource which has been requested. Once it has found it at its own end, it will construct an HTTP response. This could include, for example, an HTML page. That page can be styled using CSS, and some programming logic related to that page can be written in a JavaScript source file, which makes up the response package. The focus of this learning path is on this specific element of an HTTP response. The response can also include other elements such as images, which could be embedded within HTML pages, and you could also have videos which are part of the page. So whenever you make a request for a web page or any other resource on the internet, you typically get a bundle of resources in the HTTP response. These include the HTML, CSS, the JavaScript, images, and videos. In this entire interaction, the role of the web browsers is to formulate the HTTP request and also to pass the HTTP response. They know exactly how to display the resources which make up the response in a form which is understood by human beings. In the best of cases, this can take the form of a nice interactive website with interesting images and videos. The role of the web server is to receive HTTP requests for resources, and they should have the ability to figure out where exactly those resources are located at their end and then serve them to the one making the request. In the scenario just described, the web browsers are considered to be the client side and the web servers happen to be the server side of the web application. So now that we know that web servers will serve up HTML, CSS, JavaScript, and so on, how exactly is a client such as a web browser able to make any sense of them? Well, this is because pretty much any modern web browser has the ability to interpret HTML, CSS, and JavaScript. The main focus of this learning path is on writing JavaScript code which can be executed by a web browser. At this point though, let us turn our attention towards HTML, CSS, and JavaScript and see how all of them fit together in order to display a web page. So what exactly is HTML? Well, you can think of this as the skeleton of your web page. It specifies exactly what the contents of your page are, what structure they need to take, and also determine what the page will finally look like to a great degree. So it is not that different from the skeleton of a human being. However, in order for our web page to take a more human form, we need much more than just a skeleton. For the web page to have a good look and feel, we need some skin over the structure laid out by the HTML. And this is precisely where CSS comes into the picture. If HTML is the skeleton, then the CSS is the skin of a web page, and from the point of view of the end user, it determines the look and feel of the page, since it includes various styling elements. Alright, so HTML determines the overall structure of a web page, such as where different elements will be displayed, whereas CSS specifies the styles for these elements. So given this, where exactly does JavaScript fit in? Well, you can in fact think of JavaScript as the brains behind the web page. One definition of JavaScript is that it is a programming language which runs inside your browser and then lets you control the behavior of the web page which is being rendered. Let us focus on different aspects of this definition. First of all, JavaScript is very much a programming language and is a very sophisticated one at that. It has the ability to run inside your web browser, and most browsers include engines to interpret JavaScript. And the purpose of having JavaScript included in your web page is to control the behavior of elements within your page. So while the HTML of a web page may determine what elements are included within the page and where they will be placed, the CSS can determine the styles related to the elements, but JavaScript has the ability to alter each of these based on logic which has been coded in by the JavaScript developer. Let us now dive a little deeper into the different aspects of this definition of JavaScript. Firstly, on the fact that it is a programming language. As mentioned earlier, JavaScript is very much a full-blown programming language, and you can think of it as being as sophisticated as C++, Java, or Python. If you have prior experience in any of these programming languages, JavaScript will not be too difficult to pick up. This is because JavaScript includes a lot of constructs from those languages, such as objects, inheritance. There are very complex function constructs and many other features. Throughout this learning path, we will cover a lot of the quirks of the JavaScript language, which make it very different from other object-oriented languages. The second part of our JavaScript definition alluded to the fact that it runs inside a browser. In fact, the JavaScript code is just-in-time compiled and then executed by an engine in most web browsers. Since browsers make up the client side of any web application, JavaScript is often considered to be a client-side technology. However, with the popularity of Node.js, which allows JavaScript code to be executed outside of a web browser, the language is being used more and more on the server side of web apps as well. While JavaScript on the server side is not the focus of this learning path, the language itself, including all of the constructs and syntax, is exactly the same. So this path will help you in developing Node.js applications as well. The final part of our JavaScript definition describes that JavaScript can be considered the brains of a web page. While the HTML and CSS determine the layout and styles, JavaScript itself can control each of these, and in addition, it can also participate in communications with the server side of the application, client interactions, and much more. We will see soon enough that JavaScript is extremely versatile and quite powerful. And given that, it is good practice to follow this tip. Client applications in general should be kept rather small and simple. This is because many of these apps will end up running on devices such as mobile phones, which have limited processing power. So if there are any complex operations which need to be done by a web application, you should try to perform this on the server side and limit the scope of your client app. We have discussed the fact that JavaScript code has the ability to modify the appearance as well as the behavior of a web page. To enable that, JavaScript needs to include several features which allow it to manipulate the document object model, and we will now focus on the fundamentals of JavaScript as a programming language. Previously in this course, we have discussed the fact that JavaScript is by all means a full-fledged programming language, not very different from object-oriented languages such as Python, C++, or Java. Given that, there are several features which you can expect JavaScript to possess. Let us take a look at some of the high-level features of JavaScript. For one, it is possible for you to have variables, which of course are a rather basic feature of a programming language. Beyond that, JavaScript also includes functions, and you will soon see that functions in JavaScript include many features which functions in other languages do not possess. In JavaScript, there are also some of the basic looping structures, such as while loops and for loops, and also other control structures such as if statements. In order to work with sequences of data, JavaScript also includes array structures, and to work with more complex data, there are also objects in this language. If a language has objects, then you can expect that it also includes features such as object blueprints or templates, and also inheritance. And given that JavaScript can be interactive in nature, it also has the ability to accept input from end users and to generate output to convey information to them. Do keep in mind that these are just some of the high-level features of JavaScript, and there are many others related to the ones just listed here, which can get rather complex. Let us now turn our attention to two of the features which we just discussed, namely functions and variables. When it comes to the creation of these, functions and variables in JavaScript are created the moment the web page related to a JavaScript source file has been loaded in your browser. Given that, you should also be aware of when exactly functions and variables are destroyed. This will happen the moment you navigate to a new web page from the browser. So it is important for you to know that functions and variables will not persist across multiple pages in your browser session unless you explicitly make provisions to handle that. Which brings us now to a rather interesting topic in JavaScript, which is the scope of your variables. In fact, this is a very complex topic, and it's something which even experienced JavaScript programmers may often struggle with. To start off though, the scope of variables can be rather simple. You can have global variables which are accessible as long as a particular JavaScript source file is active, which means that the web page which it is related to is still being rendered in the browser. As opposed to global variables, you can have variables which are also local, and this scope is often local to functions and a few other constructs. So just to summarize, in the case of global variables, these continue to exist as long as the page which a JavaScript file is linked to is loaded in the browser. The lifespan of local variables is usually more limited, where they may exist inside a function or a block of code such as a for loop, for example, or some other specific scope, which we will get into a little later. And an important thing to keep in mind with global variables is that they come into existence as soon as the page loads in the browser, and the moment a user navigates to a different page or closes down the browser, those variables cease to exist. Given the specifics of global and local variables, let us take a look at some of the features of variables in general. So in JavaScript, it is possible to work with variables without explicitly declaring them first. This is clearly an indication that JavaScript is not strongly typed. So you don't need to assign a type to a variable before you put it to use. However, one caveat of using undeclared variables in the language is that they end up having a global scope, which means that you cannot reuse the same variable names within the same source file. However, if you do wish to reuse some variable names, and these could include common names such as x, I, and so on, then you should declare them within a particular scope, such as within a function. So I have already mentioned that JavaScript is not strongly typed, where you don't really determine the type of a variable. So how exactly can we declare one? Well, there are specific keywords which can be used for this purpose. For example, var, let, and const often determine the scope and also the behavior of variables which are declared using these keywords. During the labs in this learning path, we will take a look at exactly what effect these keywords can have on variables. Now, I know I have mentioned this a couple of times already, but I cannot emphasize this enough. The concept of scope in JavaScript is quite fascinating, and it is quite different from other object-oriented languages such as Java, Python, and so on. And this becomes quite apparent when implementing the concept of closures, which we will cover just a little later. Moving on now to some of the other properties of JavaScript. I have already touched upon the fact that JavaScript is weakly typed. That is, the type of a variable is not determined at the time of declaration. In fact, the language is also dynamically typed, which means that a particular variable can be set to a string or an integer, and it is dynamically bound to that type when it is referenced. It is also possible to change the type of a variable by first using it for a string and then for an integer, for example. Given all of this, you may find that JavaScript seems very permissive, especially when compared to other languages such as Java and C++, which are strongly and statically typed. While this makes JavaScript extremely flexible, there are some behaviors which you need to be mindful of. For example, if you happen to be comparing a string with an integer, there may be some implicit type conversions which are taking place under the hood in order to perform that comparison. Unless you're fully aware of exactly what the values might be, these implicit conversions could lead to unpredictable results, especially since JavaScript will tend not to raise an error in many cases when incompatible types are being compared. Given all of this, you could consider enabling strict mode in your JavaScript code, which does limit the flexibility of JavaScript. However, it also imposes some rules which could restrict the throwing of unexpected errors. So what exactly happens when you enable strict mode? For one, it prevents the use of undeclared variables. This means that you don't inadvertently create a global variable, which could, of course, have unexpected repercussions. The enabling of strict mode also does not permit the use of some reserved keywords as the names for variables and functions. For example, the keyword undefined has a special meaning in the context of JavaScript, and without strict mode, it is possible for you to have undefined as a variable name, but this is not permitted when you enable it. Beyond that, enabling strict mode does have the effect of preventing certain coding practices, which could get in the way of the JavaScript engines optimizing your code. And another important factor is that by enabling strict mode, your code is more likely to throw up errors rather than failing silently when certain unsafe operations are performed. This has the effect of immediately drawing your attention to code, which could lead to problems further down the line. More generally speaking, though, enabling strict mode when writing your JavaScript code is considered to be more secure, even if it imposes some restrictions on what your code is allowed to do. During the lab section of this learning path, we will be using strict mode for nearly all of our demos. Having been introduced to variables in JavaScript, we now turn our attention towards arrays and functions. Starting with arrays, in JavaScript, as in any other language, arrays are pretty much variables which contain a sequence of values. The emphasis here is on the fact that there is a sequence of the elements in an array, and that the ordering does matter. Unlike some other programming languages, however, arrays in JavaScript can be heterogeneous. This means that the array elements need not all be of the same type. You could have integers, strings, or even arrays themselves, which are the elements of an array. Furthermore, the length of any JavaScript array is not fixed. So even after an array has been initialized, you can add elements to the array and also remove them. And when it comes to copying arrays, it is possible for you to create both shallow as well as deep copies. Now, what exactly is meant by shallow and deep copies? Well, in the case of shallow copies, if you have an array X and you create an array Y, which is a shallow copy of X, X and Y are effectively different variables which point to the same underlying data. As opposed to this, in the case of deep copies, it's not just the variable names which are different, but the data they are pointing to are also independent of each other. With shallow copies, if you alter the contents of one of the copies, since the other variable points to the same underlying data, that array is modified as well. However, this is not the case with deep copies since they are entirely independent of each other. With shallow copies, there are multiple ways to create such arrays in JavaScript, and we will explore a handful of these techniques during the labs of this learning path. What we will also cover is the creation of deep array copies using the slice method. Moving along now from arrays to functions in JavaScript. And one thing to keep in mind is that in this language, functions can be treated like any other value, such as numbers or strings. For those coming in with a background in other languages, this is something which can take some getting used to. And this brings us to the fact that in JavaScript, functions are considered to be first-class members. Now, what exactly is meant by this? Well, you can say that there are three properties of JavaScript functions which make them first-class members of the language. For one, you can define functions in JavaScript which take in another function as an argument. Beyond that, you can also have a function return a function as its return value, and you can also store a function in a variable or as an element in an array. So in this manner, functions can be treated very much like strings or numbers or any other member of the JavaScript language, which is why functions are deemed first-class members. So note the three properties which we just discussed: the ability of a function to take in another function as an argument, its ability to return a function, and being able to assign functions to variables. During the labs of this learning path, we will come across several examples where we make use of each of these properties. And even if you find such behavior kind of hard to get used to at first, it won't be long until you're very comfortable with treating functions as any other type in a language. At this point though, I'll just introduce another term in JavaScript, which is a higher order function. So this is a special type of function which is able to operate on other functions, either by accepting a function as an argument or by returning a function itself. You will see in the examples in the learning path that such use of functions is rather common. If you want to tell a function to execute a specific function after it has performed its own tasks, you can supply it as an argument, and in many cases, it is the task of a function to construct another function call which can be invoked at a later point in time. And this is where a higher order function will return a function itself. In this video, we will take a look at the concept of objects in JavaScript. We will discuss how exactly they are represented, what they can contain, and also how we can define a blueprint for an object out of which multiple objects can be created. So, in the world of JavaScript, what exactly is an object? Well, the most simple definition is that it is a set of key and value pairs. The keys in this case are usually in the form of strings, but the values themselves can vary. They could be primitive types such as numbers, strings, or booleans, but also more complex types such as arrays, functions, or other objects themselves. So each key and value pair within an object is called a property of that object. There are other terms used to refer to them, such as attributes or entries. You can in fact think of JavaScript objects as being similar to maps, dictionaries, or associative arrays in other programming languages. And if you have a background in other languages which use such constructs, it should not be too difficult for you to work with objects in JavaScript. Again, I will emphasize that the values within an object can take on complex forms such as functions and also other objects, which are referred to as nested objects. Another property of objects in JavaScript is that it is possible for an object to inherit properties from other objects. There are also mechanisms in place to create a new object out of an existing one. So once you have created an object, it is essentially a collection of key and value pairs or properties. And even after the initialization of the object, you should keep in mind that it is possible for you to add or even remove properties on the fly. So by default, an object is not frozen once you have initialized it. You can constantly keep modifying it by adding or removing properties or by editing the existing ones. So how exactly is an object represented in JavaScript? Well, here is a sample of the syntax which is used. So consider that you have a pet dog named Speedy and you wish to represent it as an object in JavaScript. So you have a variable called myPet, which is declared using the let keyword, and the object definition itself is within curly braces. Within these braces, you have a collection of key and value pairs for the object. The first key is type, and its corresponding value is the string dog. Similarly, you have name and speedy, which make up the second key and value pair. And you observe that there is a key called age, whose value is a function, while the key siblings has a value which is an array of objects. This syntax will be familiar to anyone who has made use of the JSON format. In fact, JSON is simply an acronym for JavaScript Object Notation. So it is no coincidence that JavaScript objects have the JSON structure. So objects in JavaScript, like in any other language, can be used to represent any kind of data. And very often, you may wish to copy an existing object in order to create a new one. Like we discussed with arrays earlier, objects can have deep as well as shallow copies. In the case of shallow copies, you may have two different variables which point to the same object underneath. And in the case of deep copies, they are entirely independent variables. An important thing to keep in mind if you're passing along objects as arguments to functions is that when you do that, it is the reference to the object which is passed, which means that if the function performs any modification on the argument, your original object will get changed as well. This in fact contrasts objects from other primitive types in the JavaScript language. So for example, when strings or numbers are passed along as function arguments, they are passed by value and not by reference. So in case you're not familiar with these terms, what it boils down to is that when you pass along strings or numbers as function arguments, the function will be working on copies of those variables with the same value. Any changes which the function performs on the arguments will only affect its local copy, and the original variable which was passed to it as argument is not affected. This, however, is not the case when you pass objects as arguments to functions, where any modification performed by the function does modify the original object because the function is simply working on a pointer to the same underlying data. Since objects in any language are used to represent some entity, the question you can ask is there a way to define a blueprint from which objects can be created? For example, you may have an entity such as an employee, and for every employee which you wish to store details for, you may have fields such as their name, their employee ID, their date of birth, and so on. For every employee, you may also have a function to calculate their date of birth, to print out their details, and much more, in which case it is helpful to have a template where all the common properties are defined, and then you can create new objects out of them. Well, this can be accomplished in JavaScript by means of object constructors, and we will see exactly how these can be used in the lab section of this learning path. For now though, let us take a closer look at some of the properties of these object constructors. We have discussed that they effectively serve as a blueprint for JavaScript objects, and these object constructors in JavaScript are in fact special kinds of functions. It is these object constructor functions which serve a purpose similar to classes in other languages such as Java or C++, where you bundle in all of the different fields which make up an object along with the functions which they must have. Once you have this blueprint or template, you can create new instances out of them by making use of the new keyword. Once again, this is similar to classes in C++ and Java. So just a little earlier, we saw an example of an object which represented a single pet. So how exactly can we define a blueprint or a template for multiple pets? Well, here is an example of an object constructor for a pet. Since an object constructor is essentially a function, we use the function keyword, and this is followed by the name of the function, which in this case is pet with an uppercase P. So this uppercasing of the first letter is not required, but is a convention in JavaScript. This function accepts a number of arguments which represent the values for a pet which need to be supplied when a new pet instance is created. In the last line here, you can see how a new instance of a pet can be created by using the new keyword along with the values for a pet. Those of you who have a background in C++ or Java will recognize that this particular syntax does have a resemblance to classes in those languages, except that the class as well as the constructor are effectively rolled into one here. But for people who do have a background in such languages but find the syntax a little hard to work with, JavaScript does offer classes as well. The definition of classes in JavaScript is not very different from C++ or Java or Python, but you should be aware that under the hood, JavaScript is in fact implementing object constructors. The use of the class keyword and its specific syntax is merely syntactic sugar over these implementations. It is also possible to implement inheritance in JavaScript when you make use of classes, and this is done by using the extends keyword. Again, this type of inheritance is not really a separate feature in JavaScript because behind the scenes, JavaScript is instead implementing something known as prototypes in order to achieve inheritance. What exactly prototypes are is something we will explore just a little bit later. We have already discussed some of the core types in JavaScript, such as arrays, objects, and also functions. In each of these cases, you may have come across ways in which JavaScript is rather different from other programming languages. And before we get into some of the more advanced topics, such as prototypes and closures, we should take a look at some of the other quirks of the JavaScript language, which can take some getting used to. So we have already touched upon the fact that JavaScript has a number of different quirks. These can be very annoying when you start programming in JavaScript, but just like with quirks in human beings, once you approach it with the right attitude, they can become rather interesting later on. So what exactly are some of these JavaScript quirks? Well, there are quite a few to speak of, but some of the main ones are the fact that there are strange special values in the language. We will get to those in just a moment. We will also explore the behavior of string and numeric operations, especially the implicit type conversions which occur under the hood when you operate with strings and numbers. There are also some equality operators in JavaScript which do not appear in many other languages, and there is also the concept of truthy and falsy, which are values which are not exactly Boolean true or false values, but can be equated as such. So now that you have some idea of the different categories of quirks in JavaScript, let us dive right in to the first one, which is special values in this language. One such special value is undefined, which represents a variable which has been declared using the var, let, or const keywords, for example, but it has not been set to any value. A related but subtly different value in JavaScript is null. So this is a value which is explicitly assigned to a variable as opposed to undefined, which typically is not explicitly assigned. Both null and undefined represent the absence of a value for a variable, but in the case of undefined, this is usually something which is implicitly set by JavaScript, whereas null is something which you as a programmer can explicitly assign to a variable. So while undefined and null represent the absence of a value, there are also values in JavaScript which represent some erroneous data. For example, there is a value called nan, which is short for not a number, and this is one which is often returned when there is a failure in a math operation. For example, when you divide a number by a string. Unlike many other languages, JavaScript does not throw an error when such an operation is performed, but simply returns nan. Another operation which throws an error in other languages, but does not in JavaScript, is division by 0. In JavaScript, the value which is returned is infinity. So this is also a special value in JavaScript, and we have both a positive as well as a negative infinity. A common theme with all of these special values is that JavaScript invariably ends up assigning one of these special values to a variable instead of throwing an error. And this is something we will see a lot of during the labs of this path. Moving along now to another category of quirks in the JavaScript language. And this has to do with operations involving strings and numbers. I have already mentioned that JavaScript implicitly performs some type conversions, and this is especially evident when working with strings and numbers. For example, if you were to add the number 2 to the string 3, what is returned is the string 23. This means that JavaScript has implicitly converted the number 2 to the string 2 and has interpreted the plus sign to refer to a string concatenation. As you can imagine, unless you're careful with your data, it is possible that some of your operations might return some unexpected values. And this is something you need to be very much mindful of when writing JavaScript code. The next category of quirks has to do with equality operators. Like with other languages, JavaScript has the double equal to sign, and when this is applied to two different operands, it checks whether those two happen to have the same values. And it does this by performing an implicit type conversion if necessary. So for example, if you were to check whether the number 2 is double equal to the string 2, this will return a Boolean true value. In many cases though, you may want to ensure that two operands don't just have the same value, but are also of the same type. In such a case, you will need to make use of the triple equal to sign. So this is the strict equality operator. It ensures that the two operands are not just equal in value, but that their types also match. So there are no implicit type conversions when this equality operator is used. So what exactly is the inverse of these equality operators? Well, the double equal to is complemented by exclamation equal to or not equal to, whereas the triple equal to sign gives the opposite value as exclamation point double equals to. So while the double equal to may perform a type conversion, triple equal to never does that. But you should keep in mind that when working with objects, both equality operators work in exactly the same manner. That is, there is no implicit type conversion here. Moving along now to the last of the categories of quirks which we had for JavaScript. And this has to do with values which are either truthy or falsy. So anything which JavaScript can convert to a Boolean true value is considered truthy. So if a value is being evaluated, if it is not explicitly a Boolean value, JavaScript will try to perform an implicit type conversion so that it is forced into some Boolean value. For example, non-zero numbers, non-empty strings, as well as non-empty arrays are considered truthy in JavaScript and will evaluate to a Boolean true if they are being referenced in an if statement, for example. On the other hand, anything which JavaScript is able to convert to a Boolean false is considered falsy. Some examples include the number 0, an empty string, as well as the special values of undefined and null, which represent the non-existence of a value. Empty objects and also empty arrays are also considered falsy since they evaluate to a Boolean false. So now that you have an idea of the different quirks in the JavaScript language, you can move on to some of the more advanced topics such as closures, which we will evaluate in the next video. The fact that in JavaScript, functions happen to be first-class members means that we can have the return values of a function be other functions themselves. But when we do that, is it just the function body which we return, or is there a little more? Well, this is something which we will cover in the topic of closures in JavaScript. So what exactly is a closure? One way to define it is that it is a package of a function along with its enclosing environment. To get a clearer idea of what this means, we can take a look at a real example of a function which returns another function. So here we have outer function within which a variable name is declared, and then we have a nested function called displayName within outer function, which references this name variable and simply prints it out to the browser console. Console.log in JavaScript is simply the equivalent of a print statement. Now let us focus on the line here where a variable called nameFunc has been defined, and this has been set to the return value of outer function, which of course is the displayName function. So when outer function is invoked, it ceases to exist right after the call is completed. So it returns the function displayName, and this is assigned to name function. Note here that the displayName function has simply been returned and not invoked just yet. Now, given that outer function ceases to exist after this line, what happens when we execute the returned function here? Given that the function displayName references the name variable which is defined within the scope of outer function, will that variable be accessible when that function ceases to exist? Well, the answer is yes. So when this function is executed, it is still able to access the variable which was defined outside of it. And the reason for this is that this nested function within outer function was in fact packaged with its surrounding environment. So when the displayName function is returned by outer function, it is not simply the function body which is returned, but also the variables available in the environment immediately around it. It is this combination of the function along with its enclosing environment which makes up a closure in JavaScript. The concept of closures in JavaScript is a rather important one. So let us now try to visualize this by means of some diagrams. We start off with an outer function definition which has a nested function inside it. Within the body of the outer function, but outside the nested function itself, we have a few variables which are declared, and these variables can be accessed within the nested function. This nested function, though, does not exist in isolation of the outer function, but is in fact a member of a closure which includes the nested function along with the variables in the outer function. So, what exactly does this mean? Well, we have already touched upon the fact that closures are an important concept in JavaScript, and one reason for this is that they offer ways to get many complex things accomplished. For example, we can implement private variables in JavaScript by means of closures, where variables can only be accessed from within a function since it's part of the closure, but they cannot be accessed outside of the closure itself. Furthermore, the idea of closures is heavily used in order to implement JavaScript frameworks such as jQuery and Node.js. So variables declared in the enclosing environment can be accessed from within functions because they're part of the closure scope, which now takes us back to the concept of scopes in JavaScript, where we have already discussed the fact that we can have global variables which can be accessed from anywhere within the JavaScript source. There are also local variables whose scopes are limited to functions or blocks, and beyond those, we can also have closure variables which can be accessed inside of a closure. So these are variables which are defined outside of a nested function but can be accessed by the function itself. And beyond that, we can also have variables defined inside of the nested function. So earlier on, we just discussed the concept of global and local scope for variables in JavaScript, but with the introduction of closures and nested functions, you can see that this concept does get rather more complex. And one thing to keep in mind is that variables inside of a closure supersede variables of the same name which are defined in any outer scope. Since the global scope is the ultimate outer scope, closure variables can override global variables. We will now examine the concept of prototypes in JavaScript, and this is one which is closely related to how inheritance is implemented in this programming language. Prototypes and inheritance, though, very much affect how objects are created and treated in JavaScript. So let us quickly revise what exactly an object is. In its simplest form, we can consider that an object is a collection of key and value pairs, ranging from primitive types such as strings and booleans to more complex types such as arrays or even objects themselves. We have covered the fact that an object constructor can be used in order to define the blueprint or a template for an object. So let us bring up an example of such a constructor. So this is one called book, and this accepts 4 different arguments: the title, the author, the number of pages as well as the price for a book. So let's just say you are a bookseller and you wish to store information about a number of different books. You can have this object constructor for a book and then create an instance for each book in your inventory. You can imagine that the number of book objects you have can go up to thousands, if not tens of thousands. Now, each time a customer purchases a book, you may wish to calculate the total price of the book, for which you can define a getTotalPrice function. This, of course, will reference the price field for a book, but that is just one of the pieces of data which the function works with. To calculate the total price, this function may account for factors such as regional taxes. There may also be some discounts which need to be applied, and these in turn could be based on the specific date of the purchase, the region, and perhaps some other factors as well. So, given that this is something which is required for every book, we could include the function definition within the object itself. Since the values in an object can also be functions, this is not at all a problem in JavaScript. So, for the potentially tens of thousands of book objects which you may have, you will store the title, the author, the number of pages, and the price for each book. And each of these objects also has a getTotalPrice function. All well and good, right? Well, if you really think about it, this is not really the most efficient way to define an object. It makes sense that for every single book in your inventory, you store its title, author, and so on, since each of these properties is unique to each book. The getTotalPrice function, on the other hand, is something which derives the total price based on a number of values. And it makes sense here to have a common function which can work with any book object. With our current design, for the tens of thousands of book objects, we'll have tens of thousands of copies of this getTotalPrice function. To visualize this, imagine that we have 4 different books here, each of them with their own title, author, and number of pages properties, but also a getTotalPrice function. And as discussed, since the function performs the same operation no matter which book it is attached to, it doesn't make sense to have 4 different copies here. However, we can make this function a prototype, which means that all instances of books will use just a single copy of the function. So, instead of 4 different copies of getTotalPrice, one for each book instance will instead have a pointer to a single getTotalPrice prototype function. A simple pointer will take up far less space than an entire function definition, so this implementation is much more efficient. But how does this affect the definition of the book object constructor? Well, we simply need to define the function to be a prototype by defining it as book.prototype.getTotalPrice. This will ensure that just a single copy of getTotalPrice is created, and that every single instance of book which is instantiated will point to that same single prototype. I had mentioned earlier on that prototypes are a means of implementing inheritance in JavaScript. To understand how that works, let us modify our current example just a little bit by adding a little more complexity. So let's just say that we are not just booksellers, but that we sell a variety of different products. In addition to books, let's just say we also sell hard disks in our store. So in this case, we will not just have a book object constructor, but one for hard disks as well, and there will be a number of different properties for each of these objects. For books, of course, there will be the title, author, the price, and so on. And for hard disks, we may store information such as its storage capacity, the manufacturer, as well as the price and the seller. For both of these kinds of objects, though, we have a getTotalPrice function. You can imagine, though, that such a getTotalPrice function will be the same whether it is for a book or a hard disk. So how exactly can we have common functions defined across all product types? Our goal here is to have a getTotalPrice function which applies to both hard disks as well as books. Since the logic will be pretty much the same, it makes sense to just have a single definition so that if we were to change the logic, we can do it in just one location rather than for each and every product. To phrase it differently, what we really want is for a single getTotalPrice function to be inherited by our book and hard disk objects. Well, as you may have guessed, we can make use of a prototype in order to accomplish this inheritance. Since both books as well as hard disks are examples of products, we can have a single product prototype which includes the definition of the getTotalPrice function and which is inherited by all books and hard disks. So how exactly can this be done in code? Well, consider that we have a product object constructor which includes a definition of getTotalPrice. Since this is meant to be inherited by different product types such as books and hard disks, we should have a type field, and in this particular definition, we have set this type value to be passed in as an argument to the constructor. Following that, we instruct the book object constructor to use the product as a prototype. This will create a single product instance of type book, which includes a copy of the getTotalPrice function. Any book instance which is created out of the book object constructor will have a reference to this product prototype. Similarly, we create another product instance of type hard disk, which also comes with its own copy of getTotalPrice. And all hard disk instances will point to this prototype. So in this manner, we only need to define one version of getTotalPrice, which is inherited by all product types. And this is the power of prototypes in JavaScript. This course was an introduction to JavaScript from a theoretical standpoint. We began by looking at what role is played by JavaScript in a web application and walked through the features of the JavaScript programming language. We delved into functions which are treated as first-class members of the language and also examined arrays. We discussed how objects are defined in JavaScript, which included the use of object constructors. And finally, we looked at two crucial concepts in JavaScript, namely closures and prototypes. At this point, you will have the strong conceptual base necessary for you to dive right in to some hands-on JavaScript coding, which you will find in the course Getting Started with JavaScript Programming.